All right, if you go to the home page for CIS 150 in Canvas and you look at assignment 2, which this says is due Friday, I will probably shift that due date back because I'm a little bit behind here. And you click on assignment 2, it will tell you that there are two pieces to it, piece 1 and piece 2. I will shift this assignment due date back. The first piece says complete the even numbered exercises from the variable worksheet found here. And if you click there, you will get to this document right here, which has about 24 problems, and you're only supposed to do the even numbered ones, problems 2, 4, 6, etc. The odd numbered ones we usually do in class, so I'm going to do them right here on the screen. Now this is just practice with using variables, and most of it is not too tricky. Matter of fact, most of it is supposed to be extremely simple. You're not expected to struggle with it. It's just, again, sort of like the first assignment. It's supposed to make you do certain things enough that you sort of get them in your head, and then the tricky stuff comes later in the course. But you do need to be a little bit careful because there's about 4 different sets of instructions here, and where there is a tricky part, it's that later in the worksheet, when the instructions change, it's easy to get things wrong. And the last couple, there is some thinking to do. So it starts really simple, but then it gets fairly tricky. The point of the whole thing is to get you used to variables and put statements. And so it's all sort of silly at the beginning, but then it gets some interest as we go along. So I'm going to work through every single one of the odd numbered ones from here to the end of the worksheet. And then that'll be that for this video. So the first problem says the first 6 problems, the instructions are, what do the variables contain after the given declarations and put statements? So you can see number 1 here, I have 3 declarations, num1, num1, num2, num3. All right, so the first thing I want to say is, one of the things I told you before when you create variables is they should be meaningful. Num1, num2, and num3 are definitely not meaningful. So this is not following my instructions at all. But the point is we don't have a program here, so there really is no meaning. So I'm just picking meaningless ones. So I'm calling them num1, num2, num3 for number 1, number 2, number 3. The second thing is that the first thing here, the num, which is, you're seeing this on my editing screen, so it shows up with a red line to show that it's misspelled. That's because Word doesn't know, or PowerPoint doesn't know what we're spelling here. That first thing, num, is the type. Then the second thing, num1, is the variable name. So don't, like down below I have num value 1. So don't mix up what I've got here. The name of the variable is simply num1, not num1, just num1, and num2 and num3. Okay. What we've got is, in this case, an initialization with each one, so that num1 gets a 6 in it, num2 gets a 3 in it, num3 gets a 2 in it. So down at the bottom in the answer, I've got 3 different squares, and you're supposed to eventually fill in what is in those squares. So I'm going to write them on the right over here. We've got 3 squares. This is going to be sloppy, but I think you can see it anyway. Num1, num2, and num3. The first one is actually called num1. Oops, I'm really sloppy here. The second one is actually called num2. The third one is actually called num3. Takes me a while to get used to using the light pen. But when they start, this is the important thing. There's a 6 in here, and a 3 in here, and a 2 in here. And then, after all that's set up, then we have the 3 put statements, which we do in order. First one says put num1 plus 1 in num1. So we take num1 plus 1 and calculate that. That means we take the 6 plus 1, which is 7, and put the 7 back into num1. So the first thing this does is put a 7 back in here. The second one says put num2 plus 1 in num2. So we have num2, which is 3 plus 1, and put 4 back in here. The third one says num3 plus 1 in num3. So that puts a 3 in here. So this is a little hard to read here. That's a 4. So we get 7, 4, 3. When you answer it, you can leave scratch work like this if you want, or you can just answer it with 7, 4, 3, right like this. You can either print out the page and actually fill in the numbers, or you can write down on a separate sheet of paper that the answer for problem 1 is 7, 4, and 3. Anything that gives me the answer. Except you're not doing problem 1, you're doing 2, 4, and 6. All right, let's do problem 3. Problem 3 has 4 variables, value 1, value 2, value 3, value 4. So let's put those in here. Value 1, value 2, value 3, and value 4. Okay. Sorry, it takes my light pen is very slow to respond sometimes. So this is value 1. This is value 2 over here. This is value 3 down here. This is value 4 over here. Okay, they start, value 2 starts with a 4 in it. And value 4 starts with a negative 2 in it. So one thing to notice here is it is possible to have negatives. The computer can handle calculations with negatives just fine. All right, value 1 doesn't have anything, so that means it starts undefined. So this will have a question mark. And value 3 starts undefined, so this will have a question mark. Okay, now it says put value 2 times 3 in value 1. So value 2 is 4. 4 times 3 is 12. 12 goes into value 1. So this question mark over here, well, I really can't get my light pen to respond. This question mark over here gets a 12 in it instead. Here, let's redo that slightly. 12. Come on. Okay, so I'm going to keep having trouble with the light pen. I'll try not to always comment on it as I go forward, but just recognize if I seem to have trouble writing, it's that I can't figure out how to get the light pen to work well. Okay, then it takes value 4 minus 1 and puts that into value 3. So negative 2 minus 1 is negative 3. So we end up with a negative 3 down here instead of this. We get negative 3. Okay, so that's my answer. 12, 4, negative 3, and negative 2. All right, number 5. Has 4 variables. This time I'm calling them A, B, C, and D. Notice again the variables are A, B, C, D, not num A, num B, num C, num D. The nums are merely the types. So A, B, C, boxes in which variables of values are stored. Boxes with names. This one is named A. This one is named B. This one is named C. This one's named D. Okay. A over here has a 5 in it to start with. B has a 3 in it to start with. C is undefined to start with, so we'll draw a question mark. D has a 4 in it to start with. And then we say put A plus B in C. So A plus B is 5 plus 3, which is 8. That goes into C, so C now has an 8. And put A plus D times 2 in D. 5 plus 4 times 2, that's 5 plus 8, which is 13. Now the thing to notice here is that A plus D times 2. Oh, come on. A plus D times 2 works the way it always works in math. The times happens first, as though it was parenthesized. So make sure you do plus and minus after division and multiplication. Make sure you know the order of operations. Okay, that's that answer, 5, 3, 8, and 2. Next page. The next page is number 7 and 8, and there's new instructions. The instructions say what one set of put statements would produce the effects shown. So the idea is that I give you 3 different examples. So in every case I have 3 variables. Num1, num2, and total. And in the first example, they start with 8, 2, and question mark. Let me list them down here. 8, 2, and question mark. And they end up with, you can see on the right, 8, 2, and 6. So the first two don't change, but the third one becomes 6. For the second example, the same three variables start with 7, 5, and question mark. And they end up with 7, 5, and 2. And for the third example, they start with 0, 3, and question mark, and they end up with 0, 3, and negative 3. So you're supposed to figure out what is it that we're doing in every case here to get to the right answers in every single case. So the idea is there's one thing you can do, or set of things you can do, that will work for all three cases. And you probably figured it out. What we're doing in every case is taking num1 minus num2 and putting it in total. Okay, I've switched over to just using a blank document. I'll have to type to get the rest of this in. But in order to get the same results in every case, what we're doing is we're taking num1 minus num2 and putting it into total. So what you've got is this following put statement. Put num1 minus num2 in total. I guess these are capitalized because I capitalized them there, but it won't matter because it's case insensitive for our language. All right, please notice it would be wrong to say this, because the name of those variables is not num1 and num2, but simply num1 and num2. And please notice that this num1 minus num2 in total works for every single different case that I have. Number 3, you do exactly the same thing except you do it on your own. Number 8. Oops, having trouble getting to the next one. Number 9. Come on. Number 9 is the same idea. So let's look at 9. Again, now, since I don't have boxes or drawing abilities here, I'm just going to make columns. We've got num A, we've got A, B, C, and D. Imagine that I've drawn boxes for each of these. And in the first case, they start 1, 4, 5, and question mark, and end up being 2, 4, 5, and 20. In the second case, in another example, they start 2, 3, 2, and 4, and they end up being 3, 3, 2, and 6. In the third example, they start 5, 3, 1, and question mark, and then they end up being 6, 3, 1, and 3. So you can probably figure out what's going on. B and C are staying the same. Looks like A is always increasing by 1, and looks like D is always B times C. So what we need is put num1, no, not num1, put A plus 1 in A, and put B times C in D. Those two statements. And those will work. That's a single set of put statements that would work in all three cases. Those two things together will get you the answer. Now, if you'd written them the other way around, put B times C in D, followed by put A plus 1 in A. In this case, that would also have worked equally well. It doesn't really matter which one you fill in, as long as they end up both filled in. All right, 10 you do on your own, because it's an odd numbered one. Okay, 11. Instructions for 11 through 16. Find the algorithm requested. I haven't shown any variable initializations, but assume they've been initialized, and your algorithm should work for however they've been initialized. So the first one, for example, says that we have 3 variables called quantity A, quantity B, and quantity C. I don't know what they have in them to start with. I'm not going to put question marks because I don't mean that they're undefined. I mean they have something in them. And what I want to do is double each quantity. So for example, if they had, here you're providing your own examples. For example, if they had 2, 3, and 5, you'd want to end up with them having 4, 6, and 10. The idea here is that your answer will simply be the following. Put, well, what do you want to do? You want to make A twice as big. So we could say quantity A times 2 in, times 2 in quantity A. And put quantity B times 2 in quantity B. And put quantity C times 2 in quantity C. And that would work. So your answer would just be that set of put statements right there. You could also have put these in any order you wanted, or you could also have done this. Put quantity A plus quantity A in quantity A, and so on. So there's a couple different solutions here that will work, but the point is no matter what you started with in A, B, and C, this would double them all. Number 13 has three things called midterm, MIDTM, make sure you notice that it's abbreviated, final, and average. And what you're supposed to do is write an algorithm that puts the average of the two tests in average. So here's what some people give me. They say midterm plus final divided by 2 in average. And this is wrong for two reasons. First reason is that it uses this variable called average, and we don't have a variable called average. We have a variable called AVG. So if it's abbreviated up here, AVG, it better be abbreviated down here. But the second reason is that this isn't correct, because what you need to do is put parentheses around the midterm plus the final, and then divide. Now, by the way, this initial couple weeks, we do lots of little tiny bits of math, like averaging and other stuff like that. We don't do anything really complicated, but part of the reason we do lots of math is because we don't have anything else to do yet. Once we get to loops and if-thens, we're going to do less math, although still we might do some, but you'll be doing lots of other stuff. So the answer here would be this: put midterm plus final divided by 2 in average. That single statement. Oops. That's not what I wanted. Let's see, 15. Write an algorithm that would calculate the total pay for the employee from the pay rate, regular hours worked, to overtime hours worked, assume time and a half for overtime. So we've got name, rate, regular hours, overtime hours, and pay. So we're assuming we already have variables filled in with each of these things. So we've already got something filled in for the name. We've already got something filled in for the rate. That's how much they get per hour. For the regular hours, that's how much whatever the regular hours is, they'll get that rate for that hour. And then we've already got the overtime hours separated out. So they've worked like 40 hours regular and 8 hours overtime hours. Then we'll have those separated out of 40 and 8. And we want to finally calculate pay. So it'll be something like this. We could say put rate times regular hours in pay. And then we could say put pay plus rate times overtime hours times 1.5 in pay. What this is doing is, first of all, it's taking the rate times the regular hours and putting that in pay to begin with. And that's the pay without overtime. And then it's adding to that the overtime hours times the rate times 1.5, which will give us 1.5 time and a half. And we put the whole thing into pay. You could also have done this in a single statement, of course. You could have said put rate times regular hours plus rate times overtime hours plus times 1.5. Put the whole thing into pay. That would have been fine. Or you could have said put rate times regular hours plus overtime hours times 1.5 in pay. Anything that gets you the same result would have worked. All right, 17. For 17, in class, I make everybody do number 17 on their own first and see what answer they get. And I would strongly encourage you to do the same thing. It's back to the very first set of instructions. You're just simply filling in the boxes. So we've got the following boxes: num1, num2, num3, num4. And we've got, to begin with, 1 here, 3 here, 5 here, 2 here. And then we have a set of put statements. And I emphasize, make sure you go in the right order. All right, what I almost always do is have people in class, first of all, do this on their own and then turn in what they got. And everybody thinks it's simple. And then they turn in what they got, and it turns out that more than half the class gets it wrong. So I would strongly encourage you, before you go on with the video, pause it and do this on your own and see what answer you get. And then start it up again, and I'll show you the right answer. All right, so here we go. Here's the answer. If you haven't done this already, you should go do it first. All right, first it says put num1 and num2. So that changes this. Instead of 3, it now has 1 in it. Second thing is it says put num1 plus num3 and num4. So that takes 1 plus num1 has a 1 in it. Num3 has a 5 in it. That makes 6, and it puts that into num4. And then third of all says put num2 plus num4 and num1. The important thing to remember is that num2's changed. It's 1 right now. And num4 is changed. It's 6 right now. So it puts 1 plus 6, or 7, into num1. So the answer should have been 7156. The important thing is that you have to do these in the right order. By the time you come to this last statement, put num2 plus num4 in num1, you have to have already replaced what used to be in num2 and num4, because those have been replaced by the previous statements. All right. 19 is going to do something similar. Here we go. A, B, C, D. A starts as 1, undefined, undefined, undefined. We say put A times 2 in B. That will make B no longer undefined, but now 2. Put B times 2 in C. We use the new value of B, so it's 2 times 2, which gives us 4 for C. And then put C times 2 in D, which gives us 8 for D. So the answer is 1, 2, 4, 8. Okay. Next. Having trouble getting, come on. There we go. There we go. Number 21, I can't get just a little bit changed here. The instructions say find an algorithm, just like we did back before. So it's a whole set of put statements that makes this always work, assuming that it's already been initialized somehow. So we have number A and number B. The difference here is that we're allowed to use extra variables if we want. So it says write an algorithm to swap the two variables. For example, if A started as 3 and B started as 7, when we're done, we'd like A to be 7 and B to be 3. Or if A started as 5 and B started as 2, when we're done, we'd like A to be 2 and B to be 5. All right, how would you do this? Well, one way you can try to do this is like this. Put A and B and B and A. But that doesn't work, because if you think about it, let's take it with 3 and 7. When we put A and B, that takes the 3 over here and puts it over here in B, and now they both have 3 in them. And now when we put the B in A, B is 3 again, so that just puts the 3 back into A. So we end up with 2 3s. That's not correct. So you can't do it that way, because when you put A and B, you lose the old value of B. So the typical way to do this is to do it the following way. You add an extra variable. Let me call this, what we need to do is hold on to the old value of B. Let me call it old B. Some people will call it temp for temporary. And what we're going to do is we're going to start by putting B in old value of B. And then we can put A and B, and then we can put the old value of B in A. In other words, we start by putting 7 over here to hold on to it so that later it will still be around. Then we can go ahead and put A in B, putting the 3 here. And now we can take the 7 and put it back into the A. So what you're really doing is a 3-way swap. You're putting, I can't do this easily drawing here, but I can't show the drawing here, but you've got A, B, and old B. And your first statement takes A, puts it in old B. Your second statement, B and puts it in old B. Your second statement takes A and puts it in B. Right, like that. Pretend that's an arrow. And your third statement probably pretend this is an arrow. And your third statement takes old B, puts it back into A. These don't really look like arrows, but pretend they do. So you can see this sort of goes in a little circular swap. That's the typical way that people swap two numbers. Notice you can't just go straight from A to B and B to A because one overwrites the other as you go. Let's try number 23, which is a more complicated version of the same thing. 23 has three variables of A, B, and C, and you're supposed to put into each variable the sum of the other two. For example, if we started with 3, 5, and 7, we'd want 3 plus 5 or 8 to go into C, and we want 3 plus 7 or 10 to go into B, and we want 5 plus 7 or 12 to go into A. So you have the same problem as before. You have to avoid overwriting things. So you can't simply say put A plus B in C, put A plus C in B, put B plus C in A. That would mess everything up because when you put A plus B in C, it would change what was in C, and the next line would no longer be working properly. So what you have to do is somehow use temporary variables. So there's a couple ways to do this. One way is to put A, B, and C in separate variables to begin with. Put A in old A, put B in old B, put C in old C. And now you can go ahead and put A plus B in C because you still got old C to use for the rest. Put A plus old C in B, and then finally put old B plus old C in A. I suppose if you look at this, you never use old A, so you can drop that altogether. So the way you would answer these, by the way, I forgot to mention this, you would add variable declarations for the extra variables. In this case, num old B, num old C. And then you make sure your put statements use them. So the answer would be this part right there, the two new variable declarations, and then whatever you're doing here. You can also do this in other ways. You don't have to do it this way. I did it by first of all storing B and C in something else and then go ahead and changing things. You could do something else. You could do it differently. You could say put A plus B in the new C, put A plus C in the new B, put B plus C in the new A, and then you could copy them all across. Put new A into A, put new B into B, put new C into C. That would work equally well. I don't care how many new variables you have or anything else. All right, 24 you're going to do on your own, but let me just point it out. It's a little different than the others. It says, answer the question. 24, I give you an algorithm. And I say, try it out for several different initializations. Just try it for several examples. And I'm asking you, what does it do? And it is simple to describe in just a sentence or two. You don't, if it takes you forever to explain what it does, then you haven't tried it enough or you did it wrong, because it's actually very simple to describe. All right, so that is the first part of assignment 2. You may certainly start working on that, do that right away. I will show you the second part of assignment 2 later on, and but I'll probably delay the due date just a little bit so that in case I don't get to till later in the week, you've still got plenty of time to do it. Okay, thanks.